sounds like, I didn't get the official announcement, but Pascal's not gonna be with us. Did you guys hear that? I must have been out of the room. So, all right. Everybody's present. Say that again? Oh, that would explain it. Guy goes and plays hooky one day, misses all the important announcements. All right, bang, what else did I have? Who is, I'll say, not done with your batteries yet, by show of hands? I could ask it the other way around, but, so I've got Sydney, is that just one group? Are you in Martin's group?
Yeah.
All right, how, did you start on them? Where are you at?
Yeah, we're almost finished.
All right, so like by the end of the day, you'll be good. All right, and then that's the last one with batteries? Okay, cool. That's one of the ones in my head where I'm making sure you guys get done, and if you have anything you need help with, make sure I get you helped out. So, okay, that sounds great. Some of you guys were in the class when I stumbled across this. Oh, and I was like, wow, that's really cool. This battery actually has a specific gravity checker built into it. No fluid in it, so it doesn't work. I was like, man, how cool is that? So I wanted to kind of just point that out, and that would be a way to tell if your battery's charged or not charged without even taking the caps off. I think it's genius. I think probably the problem is, I got a feeling that clear plastic is not as heavy duty as the black stuff, and the battery won't last very long in an aircraft. If we were to just grab a voltmeter and check our battery, whether it's 25% charged or 100% charged, we're going to get a pretty similar number, right? So doing that doesn't really tell us how well charged our battery is. So just a review on that, if you ever have that question come up, checking the voltage doesn't do much because we get pretty much that steady voltage across the, just looking, I want to say panels. Terminals, yeah, what were the plates. Plates is the word I was looking for, and terminals took a spot. We get a steady voltage across the plates as long as there's charge there. It does move slightly, but not very much. All right, let's get into today. I had this one show up at the baseball game yesterday. It's a little bit teasing the guys across the hallway, but how can you tell if a person's a pilot, a marathon runner, or a vegan? Don't worry, they'll tell you. Yeah, that's a funny one. It's not so funny when you just told a guy that you were a pilot and then he tells you the joke. Oh, okay. I was telling my daughter that, and I was like, well, I mean, they love what they do usually, really is what it comes down to. It's not that they think they're that much better than you, but most pilots are like, this is so fun, I got to do it. Marathon runners too. I'm not sure what vegans' things are, but maybe it's because I'm not one. Maybe they're healthier. All right, so today, basically, I have like 6 of these diagrams. I think it's all of them from Prepware. If I don't have all of them, and when I say Prepware, the FAA ones, if I don't have all of them, we can find another one at a break and pop it up here. Some of these from Prepware are either reversed, they might be a mirror image from the FAA ones. Technically, they're not supposed to like mirror the exact questions, and that's when you get your writtens. That's why you can't just straight up memorize questions from Prepware, because they'll tweak it just a little bit. The truth statements should still be true or false, but sometimes the wiring diagrams are tweaked just a little bit. So I'd be a little bit hesitant to, let's say, memorize this diagram and be like, oh, I remember the answer, that one was wire 6, because they might just change which wire number is on you. Stuff's not set in stone where if you memorize this diagram, you've you've got everything memorized. So with that said, we're gonna go through these today kind of in a together form of, hey, let's sort through this thing and figure out what is it and what types of questions might they ask. I did give myself some notes because I'm gonna try not to confuse you as we do it, because these can be pretty confusing. Anytime you get this type of question on prepware or even in the real world, it's a good idea to have a pencil, have a piece of scratch paper next to you otherwise, be writing down. When you actually take your written test, they will give you a clear sheet of plastic. I want to say clear sheet of paper, but it's not paper. That you can lay over top of your figures, because you'll have a book that has the figures in it, you'll have a clear sheet of plastic, and you should have like a little marker that you can write on your clear sheet. So when you get the wiring diagram, you can lay the clear sheet over there, you can draw on your wiring diagram and trace stuff out. Same thing, you can use that for your wiring diagrams. If they don't give it to you, request it, because they don't want you writing in their books. That'll get you in big trouble. You can't like pencil lines in the figures in the book. So they should have a clear sheet and a pencil. So I'm gonna treat the board like I got a clear sheet on there, right? What's tricky with these at this level where we're teaching you is we don't know what some of these things are. I mean, we might be able to figure it out, but if we come up here, 24 volts DC, that's our bus, so that's kind of like our big positive where we've got voltage coming in to our system. So if we wanted to draw a battery on this thing, it'd be plus to the battery, and then negative off the battery is going to go to ground. So that's just kind of an understood that they figured you knew already. Makes it a little bit tricky, but as we get farther through general, that stuff will start showing up that we teach you. This one's obvious, it's a warning horn on this drawing. Throttle switches in this drawing are, if I go full throttle, which can be a little confusing when we get into that part. Full throttle means an open throttle. It's back to like a water line. If the throttle's open, that means the air can go through. So if I go full throttle, these switches are going to be in that open position. And it's open electrically when open mechanically. And the reason for that is the system is set up to do a couple things. One is the red light and the green light, that's what they're showing here, are warning lights. Is a green light a warning light? They're helpful lights. The green light's not so much warning you, but green is that pretty much you're good. You're kind of safe. Your gear is down, and that's where you want it to be because you're probably landing. The red light is basically warning light that you've got danger going on. That's kind of how these are supposed to be set up on this. The reason they'll do that is, let's say you retard your throttle. Retard means close the throttle. You don't want any power anymore because you're landing. If you retard your throttle but the landing gear's not down, the designers decided to say, you know what, let's turn the horn on so that it goes, because one of the biggest things with gear, the wheels on our aircraft, the problem with those aircraft is pilots aren't that smart. And they tend to land with the wheels up inside the aircraft. So they said, you know what, if they ever pull the throttle all the way back, but their gear's not down, let's tell them about it, because they're not that smart. So that's the idea behind this system. So what we got is a gear switch, so that when the gear is down, the switch is in this position, it's saying, hey, I'm closed. So when the gear is down, it's closed. On this one, it's showing down is this way, so when the gear is down, I'm closed. And then this is the control valve. The control valve on this one is, and let me double check, does it give me the notes? A later one has all the notes on here. I believe the control valve switch is basically saying gear down is to our left. And this is part of what you have to do when you're looking through these things, is you go, why didn't they tell me what the control valve is? The reality ends up being, if they didn't tell you, it probably doesn't matter. So, there's a piece of that. When I say doesn't matter, they might not ask you a question on that, but we'll see. Control valve switch. So what I do is when I look at them, I'm gonna say, okay, down, selected, and we'll say either up or nothing, selected. Some of these wiring diagrams are, I'm gonna use the word not complete, so we might be missing pieces. The biggest thing I can point out on these, I think, that a lot of you probably are confused on is the FAA likes this little triangle shaped thing. That little triangle shaped thing is like a finger temporary push to test. So in this diagram, if I were to come over and basically push on the triangle, it's gonna connect that switch. So that allows me to test my lights just to make sure the light bulb's good. So say I'm flying and I got the gear down, but I don't have a green light. Well, is my gear down or is it just the light bulb's burned out? So it gives me a test point. So that's basically what this drawing's doing. So let's walk through it a minute. If I want to just test this thing, if I push this with my finger, it's going to connect 24 through my light bulb right to ground. And my test light's going to come on. Oh, cool, good. The green light works. If I come over to the red one and I push the triangle, it's going to have 24 volts through my light to ground. And okay, my red light works. So that's pretty simple, right? Makes sense? If I don't push the test buttons, this ground isn't really hooked up to anything. So we're not going to be trying to get back to that spot on ground to turn any of our lights on, to turn any of our horns on. I got shocked. Shut the computer off. That's why you want to make sure your instruments in the aircraft are bonded well. All right, so that's where we're at with test lights. So, in this setting right here, we would say, hey, are any of our lights on? Sometimes you can follow it from the positive voltage and go through and it works out. So I could go, okay, so far I've got a path through my light, okay, through this switch, through that switch, all the way to ground. So right at the moment, my green light would be lit up, right? I go, okay, my green light is lit up right now, and that helps me know that, yup, I labeled this right, is down selected. My right gear switch, basically my right wheel, it's saying, yup, you're down. My left gear switch is just a switch that's on the gear when it's down. It says, yup, you're down, and everything is happy. So, green light, everything's pretty much happy. Is our horn going off? Let's see, power coming through here, through the horn. Oh, it can't get to ground, so right now our horn's not going off because there's no path to ground. But if I take the throttle and I pull it all the way back, and I close these two, so now I don't have my throttle in. Now can I get to ground? Oh, nope, I still can't get to it through there. Nope, can't get to it through there. Could I backfeed to ground? Well, not really. That's back to positive voltage, and my push to test light isn't going. So, nope, I can't get to ground. Now, in this position, from what I'm seeing, is if I pulled the throttle back and I closed these, and then I test my red light, my horn's probably going to go off, right? Because then I would have power through the switches, through the test to ground. So probably my red light's going to go off and the horn's going to go off if I push the test button. Oh, that's interesting. Question? All right. Now, if I'm sitting on the ground and I say, hey, I'm going to put my gear up. with the throttle off. And I take my selector here, and it's hard to get rid of, but I get rid of him and I put it over there. And I say, let's put the gear up. Number one, hopefully they have a squat switch somewhere. You'll learn about squat switches so that when the weight's on the gear, it'll say, we're not sending power to that pump because we don't want to put the gear up while you're sitting on the ground. They don't show that on here, so hopefully there's a squat switch that's not in the drawing. With what we have, we would say power would come through our warning horn, through our selector switch, and over to ground. So basically it's going to go, hey, you dummy, you can't put the gear up right now. You have your throttles all the way closed. The other one would be if you're flying, so now our squat switch, which isn't shown, is not engaged, so the gear could be up, could be down. If we have our control valve, we'll start with this where we're saying, hey, let's put the gear up. At this point, our power could come through the horn. If we're power off, it could, let's see here. If the gear's down, it might go off for a minute, but that's not going to last long because the gear's going to come up. So basically, we're probably not going to get a horn there on this one. So tracing it through, if we leave it in the down position, we can follow through. I'm trying to think what else we could deduce from here on our system. The idea would be if our gear's not down, I got a broken gear, I'm not going to get a light on because it's going to open that one up. Four. Here? This here, this is the part that swings. Oh, I see what you're saying. If that gear's up, that would give you a red light if that one's up. Yeah, so good observation. If my gear is over on this one, I'm not 100% sure if it goes there or not, but it gives us a terminal. What that would do is connect ground to our red light. If the gear's not down, hey, that would make sense, right? Hey, your gear's not down, let's give you a red light. It would probably also connect, if the other side were not down, if it were up to up on our gear, so you could say up, write it in. If the gear was up, now our horn, if our throttle's off, would be able to go to ground as well. Yep, there we go, good observation. What? Oh, my right gear switch. How about through here? So if you guys are like, hey, we're over, but yeah. So if the throttles are retarded, the power could come through here, back through the switch to ground. So yeah, they're complicated. So here's what's going to happen. They'll end up asking you questions like, let me erase some of this stuff. I'll leave up there. It's nice to look at them, label them what you think is up, down. And they'll say, what happens if wire number 11 breaks? There you go. Oh, wire number 11 breaks. My horn is pretty much never going to go off, right? So, that's simple enough. They'll say, will the red light light up if you push the test button if number 3 wire is broken? No, the red light's not going to light up if you push the test light if number 3 is broken. They might say if wire number 7 breaks, and then they give you options, what's going to happen? And basically, then you got to go, okay, when do we use number 7? 7 is if my gear is down. My gear is down. It allows the green light to get on. So you'd say, oh, number 7 breaks, I'm probably never gonna get a green light, even if my gear is down. A lot of these questions will be the kind that the right answer might not jump right out at you, but you look at it and say which number and cross off the ones that are incorrect. Because they might say, if wire 7 is broke, the red test light won't work when it's pushed. And you're like, well, that has nothing to do with the red test light when it's pushed, because that goes to here. So there's a little bit of process of elimination, but look at the other answers, make sure they don't make sense either. If 7 was broken, so a red light, if the gear's up, would come on here. And that's really the only time we'd want it on. If this one's up, it would come on there. So the red light would come on if either of our gear are up. And that's the main thing that, oh, if the control valve was in the up position, I got ground, that would ground through here, the horn. I don't think the red light's ever gonna go there. How would I track that? So red light power,
Goes down 4, to the left, and it's 12, 6, up to that junction at 12, then on 13.
down here then?
Yeah, and then down into ground through there, but if wire 7 is broken.
Ah, there you go. So yeah, if your control was in the up or neutral position, you could get a red light there.
So,
That would be feasible.
so the red light's always on when there's a gear up?
That would be the idea in this drawing, yeah. Yep. And it's more so you'd say if the gear's not down, and that's why it's drawn a little funny. This doesn't necessarily mean fully up, it just means not down. So say it's jammed halfway, theoretically, they're saying this switch is gonna be over here for up. So maybe I should have rewrote that and said not down. Okay, cool. So that's basically what we do with these, and like I said, trying to memorize each drawing. I mean, if you can do it, it'll help you, but they'll spin them around, they'll put them in reverse, they'll reorganize it on the page. So really the skill you want is to be able to kind of look through and say, okay, what are they trying to do here? And it's like a puzzle, or it's like a maze, right? Trying to figure out what is going on. So, this one, ooh, ay caramba. I looked at this one too and I'm like, I don't even know what's going on here. So, the idea behind this drawing is they've got a bunch of relays on a fuel system. So if you select one side of the fuel system or the other side, or dump the fuel, it's going to change your valves, change your solenoids. So the thing on this one to keep an eye on is the dotted lines, they theoretically are drawn so that the contact points, and they're showing the contact points as the heavy bars. So what they're showing is if we energize this coil, is what they're trying to draw. So if I energize that coil, essentially all these black ones that are connected to it are gonna move. So, if I come up here as a pilot and turn this valve to cross speed, that's gonna energize this, and all 4 of those sets of contacts are moving. So this one's a little bit tricky because they're like, well, if you energize this switch, how many contacts are gonna move? And having a pen or having something to draw with is really nice. So we could say that question, okay, it's gonna energize this one, 1. Energizing that is going to, well, that's gonna take power off. Ooh, that might put power onto something, and all of a sudden you start backtracking and saying, oh, I do have power on that one right now, even if I draw it in. So when this contact closes, I'm now gonna put power here at A. And depending on what's going on down here with open or close, basically that's just a valve that's gonna say move fuel or don't move fuel. So depending on how they ask the question, oh man, I'm not sure if these are gonna open or close. They're probably gonna assume I'm not thinking through the mechanical, so I'll just stop there. But where else did I get power? The rest of them aren't open yet. So far, I only have one that closed. Let's come down here, power off my bus, and this one would open, but this would close and back to there. So basically, I'm just gonna be closing some valves. So if I were to close this, I'm only seeing one relay that would close on that one. That's kind of the question they had on there. Yeah.
What about, what click is this? 13?
If I go by 13.
Center. In the middle.
This.
I think
You're giving power to A at the bottom.
Let's see. So,
that one.
yeah, and that's gonna be, if I'm giving power to this terminal, there's a kind of tough question. That's a really good observation. These are valves, so do we count the valve as opening immediately? Do we not count the valve? Part of the valves, what we're kind of thinking through is, now I'm powering it, and it's gonna go, and when it's open, the switch moves over. So that's a really good question, because if they ask that, you'd say, well, do they mean immediately, or do they mean after the valve opens, right? What they're showing here is basically this is the open position for the little motor on the valve, if I can phrase it that way. It might be a solenoid, it might be an open. So eventually, yeah, this switch is probably gonna click over to here. And if that's the case, now I'd have power up there, and now this one closes, and there's a little light in the cockpit that says, hey, your valve is open. So I'd say good observation, and depends on who's asking the question, right?
I think on your FCF relay, that one pulls the power off the closed side of your valve. So FCF's the bottom left. That one pulls the power off the one side, so it pulls the power off B,
So open the pump.
and then it moves it to A.
Because this, yeah, so what you're saying is, normally, before we did this, when it's just sitting here, I've got power that can come down through,
Yeah.
and if my valve is not in the closed position, this little swinger deal would be over on closed, and it'll turn my pump to closed. Now my pump's closed. So, that's what's showing. Now, this one that I grabbed, all relay spring load position is shown. That was my next slide, there's usually labels like this. So this one, I should have started at the beginning at that, I think, is there'll be little notes in them. The next one, I think it shows up bigger, but there'll be little notes. So you kind of look and say, are there any notes that they're telling me what's going on in this thing? So yeah, you're right, Leo. If the valve's not closed, I'd have power down to here, but once the valve closes, I believe what they're doing on this thing is they're saying, oh, once the valve closes, it removes the power from the close. And if we track it around, this is not a connection. And this is saying, hey, our cross feed's closed, so it would theoretically open that up and are just sitting with the closed position. Because when that's open, then our light that says, hey, I'm open, can't illuminate. So, that's the kind of thing they're asking on these. This one's a pretty complicated, it's how we go through the fuel system, is like, well, what do all those things mean? But, so you're just looking at the dotted lines to trace it around. So just for the fun of it, what if we switch that over to right-hand tank? If we switch it over to right-hand tank, it's gonna energize this one, which means that's gonna get energized, so that opens. I'm just gonna say, not there. This one would close, and we go, okay, so if that one closes, now I have power to this A, right? Which would want to open my valve. Eventually, that's going to flip over, but they may or may not ask that question right away. So right-hand tank, we have not done a whole lot there, other than eventually that opens. Once it does open, we might close that one, and it's going to say this light is on because we cross-fed just to our, I guess, right tank is what they're saying. So anyway, not a diagram where they're theoretically asking you how the whole system works, hopefully. They just want you to have the idea that if I power this relay, it's going to change the contact points on those four, and then you got to start sorting through, well, if it changes those contact points, is that going to change my voltage to anywhere else? So this thing is set up, sorry, back to where we were. This valve is going from, say, like a main fuel to open to the rest of the system, and I think the way it's wired is that'd be the right side, that would be probably the left side. And then you got some warning lights. So, hey, there's a crossfeed that's open, and you've got a selector to say, this is how I normally want to run. I want to turn it so that my left-hand tank crossfeed can come off, right-hand tank crossfeed, or if I connect the X feed here, I believe what it does is it opens both valves, so your fuel can go to both tanks at the same time. So that's basically what it's doing, but until we get into fuels class, like being able to picture it in your head, we'd have to spend a ton of time, and even then it's not gonna make a lot of sense.
I can't really see how the right-hand one and the left-hand one are doing different things.
Okay, so if I go to left, I'm gonna open this, and I'm gonna close that one. And this stack here is basically where things are gonna change for that. And I think what it ends up being is if we close the left-hand tank, we end up putting power on the open terminal here, on this one. And if we close the right-hand tank, we'll put it on, is it still the same terminal for crossfeed? So if this one gets closed, that would have power. So it's still gonna open our crossfeed. So that one is, oh, you know what? So that might just be the one that opens anyway. Fuel, oh, yeah, I'm sorry, I said right, left. This one's saying fuel pressure and fuel tank crossfeed. What's the difference? Yeah, me too. I don't know what airplane this is even on. And that's where it gets down to, it's like, okay, how many relays are gonna open? I don't remember this one being on many questions, but basically, that's what it gets down to, is they're just going, try to count your relays and close this one. So they might totally change it up and give you different drawings and working your way through just saying, hey, if this valve closes, and that's why I get back to like what Corbin was saying. Was it Corbin or Micah? On ones like this, I don't think they're gonna ask you to assume all the mechanical linkages are necessarily working. Like, they're not gonna say, okay, if you close it and we put power here, you know that eventually this one opens, which means that eventually fuel goes here and it fills up, and 10 minutes later, usually they just wanna know, hey, if I put power to this relay, where is immediately right now, where is power also at? They usually aren't gonna ask you to have the whole system mapped out in your head. Okay, let's take a break. The other ones, I put this hardest one in here. When I say hardest, it's like, I don't know what's going on. It's like, yeah, I'm sorry, bad question. But wanted to kind of show it up just to point out how the relays work. This one is actually a little bit easier. So we'll do a, let's say 10-minute break. Come back at 8 o'clock. I'll leave either one of these up if anybody wants to talk about one.
Are those, they called contacts on the relays move? Like the
Yeah.
black one? Are they always drawn towards the relays when the relay is
Visually,
energized?
yeah, let me think how to explain that one.
Like you would never push it into to complete the circuit, whatever.
Yeah, generally, I'm trying to think through all the drawings I've ever seen. I'm like, yeah, I believe they always are gonna be, essentially, think of it like this guy, right? So you got the coil, and then you got the dotted lines like the plunger. So pretty much the way they're always drawn is it's gonna pull the plunger in. So it's pretty much always pulling that line in. Unless, if they labeled it differently, usually what they would do is instead of giving you contacts, they might, on some diagrams, they might just give you like having a, this is sideways, but they might just have a contact like that, and they might say normally open, or they might say normally closed, and that would tell you, okay, when
It's
I.
not energized.
Yeah, when I power it, it's going to, if I was a normally open one, when I power it, it would close it then. So normally means when I'm not powered, I have no power.
So 10 would it be normally open?
Yeah, so 10 is normally open, 9 here would be normally
Yeah,
closed,
okay.
because normally means just sitting there, no power on
Yep.
it.
One of the prep orders says when you turn it to left-hand tank,
Okay.
how many relays I think get
Yes.
activated?
Yep.
And that tells us it's 3, 5, and 6,
Well,
11 and 12.
this is gonna be a contact point, not necessarily a relay.
Yeah, maybe it wasn't relay to ask, but how much?
Well, I mean, that
Pretty
would,
sure
that right
that-
there would have been considered one.
So this
I
is,
mean, it was all one.
I know they labeled them, right? They said.
Oh,
the
yeah, like
numbers.
LTS.
So it started with, no, it didn't start with 3, it started with, maybe it did start with, no, 5 and 6, they said were activated or whatever, 11, 12, and then 15 and 16. So I was wondering how they got that one to work together.
It's tricky, they don't tell you.
I wonder,
Would that be
These
because
are-
this whole thing,
These are fuel pumps. And so this is limit switches. So if the power comes down to this one,
Now pulls the other, well, you're basically, if you activate this one, you're pulling the power off this side, putting it
so
on
if you
this
put
side.
power here, what's gonna happen is this half the motor, this is called a split field motor. It's gonna turn one direction, and it'll turn, comes over here, and then when it does that, it changes this one.
Yeah, either this one or that one.
because it's not energized yet, which,
Yeah, initially, it's energized, but then it turns off. Well, it actually turns on.
Well, yeah, it closes that one and then it opens this one then.
Mm-hmm.
so you're always,
Work in series.
And turns, the other one goes, so the limits.
so if we were counting right now, yours, I think
That's
I'd
it.
count 1.
This baby's been around for, when I got my AP.
So before anything moves, we're just gonna power the pump there, right? And let's see, would we still have power here?
Nope, that would be disconnected here.
That'd be disconnected, but I would have power on this one, right? Yeah, so I don't.
Don't you love this? They love this one.
Power's removed here.
That means it's all connected,
Brought
but
in
not
here.
electrically.
Which I'm assuming means
There's like a-
eventually,
There's
after,
a
it'll
shaft
follow
that
this current
goes through, all four of these move when FCF is energized.
Maybe we should pull the question back up, so
Yeah,
if they're
let's see if I can
assuming,
find it.
yeah,
Yeah,
they're
they're
assuming
connected.
it's
you have
Electrically,
moving.
but
to, you have
not
to
electrically.
choose one of 3 options and it would give you the.
Kind of a crazy way to draw
I
it,
think
but.
the question they had assumed that those connections were made.
That one open,
Right.
oh,
From
yeah.
what I remember,
Well,
what I remember, it sounded like they assumed that if you had powered on here, you'd have to follow this up and that would connect that. Like,
All this
not
means,
just
So
to,
it's,
Is
it
this-
seemed like
seems
what I
like
Two
remember.
they're
light
saying
bulbs.
it moves.
this is
so
a
when
light
this 5
that says
opens,
fuel
does that make
pressure,
these
cross
open?
feed valve
No,
open.
this is a 5 amp circuit breaker, is what they're,
Is this a cross feed?
So
This
that's
one's
different
open.
from that 5?
This one says fuel
Yeah,
tank, cross
yeah.
feed valve,
which is weird, isn't it?
pressure, and
Well,
this
yeah, why
one's
do they label
tank.
it 5?
So
There's
one's,
another
one's
question
one,
that
one's the
says,
other.
that
That's
asks,
cross feed, this is the
what
tank.
switches,
So if this,
when
when
you do
this
this, what
takes power off the bus,
what's
this
the
is
capability?
closed,
Okay,
and
the
this is
answer is
closed,
5,
that light will be on.
13.
That's all it is a light bulb.
16 in there?
I think it's exactly what Lay was talking about.
Got to be
Might say-
energized.
Lay was asking like,
And then it said 16 switches too.
it might be that, maybe it's not 5 amp, it could be.
Well, these two are tied
all
together,
these,
they didn't
unless
put
a
it
circuit
down the
breaker,
line.
Are all the
They
same
assume
point
you know
electrically, right?
So this,
So
this
they're all
switch
connected to
and
the
this
same.
switch are connected together mechanically.
If it's just that terminal.
So when the motor goes the other way,
Maybe they're just trying to say if you put a
as soon as
voltmeter
this one
between
moves
5
at the
amps,
end of the travel,
you could use any
they
5
call
you
them
want.
limits.
But it's just.
We
the-
hit the
the
limits, like when you put your flaps
Turn
on,
that on, this thing ends up moving something.
and if you click the flaps
I
all
got
the way
the
down,
question.
flaps go,
Okay, let's see the
The
When you
question.
hit the
question
end,
is,
boom, they
energize
turn
the
off.
circuit with the fuel
That's
tank
called a
selector
limit.
switch to the left-hand position.
Okay,
And then the question goes,
When
using the
it
schematic,
gets to the
identify the
end,
switches
So
that
when
will
this one
change
gets
position.
energized,
alright, so,
this motor will
6
run,
and
run,
5.
run,
Six.
and when it hits the
Okay.
end of its
cause
travel,
those two
poof,
change,
this will go over,
6 and
and
5,
this one
Which-
goes over,
Which,
3,
automatically.
is
Yep.
that, do they give 3 or?
no, they
say
don't
you
do
did
3, 'cause technically that's,
That's what you did,
yeah, I suppose.
alright.
Well,
So you
people,
did that one,
So then 12 and 11, because 11 you took the power away,
alright, so they are assuming the
yeah.
pump runs,
they moved together.
So,
alright.
yeah, but
So
they
if
don't
that's the
move at
case-
such a limit. They move, when they do move, they move together.
So if they move then, so then you got
Same
12
with
would
12,
energize this.
19 and 20.
and then somehow they got 13, so then you brought power down.
So that would
We
be
got, yeah,
the switch
13
move
makes sense.
So then,
13.
but then somehow it jumps over to 15 and 16.
Well, 15 makes sense, cause if 12 closes,
Oh yeah,
Or
that's
11.
from the other side.
then you no longer have,
This
So
would
you
jump
pulled
6 to
15
here,
off,
Yeah.
doing that, because it's normal,
de-energizes that
yeah,
one.
normally open. But then somehow
Actually, would that
16,
de-energize that?
so that's de-energized now because you
Yeah.
removed it at 5.
Yeah, it means it's gonna move.
Yeah,
right, so it springs off.
So that one sprung off. Does that mean 16 is in connection with that one?
No, it's
Where's that?
separate over here.
Because somehow
said
that one also got affected.
Uh-huh.
But
Over here,
not
though.
20?
Is it simply just
How did that
from
happen?
5 on the right? And
think
it-
it's,
and it's in the,
Yeah.
that's all that's happening. So the power's coming
Yeah,
down
here's-
through 20,
Right,
if
three
it's
quarters.
closed, it goes up to 16 and energizes.
What the?
They
So I'm
love this.
still wondering how the 16 went.
I think it's just because if you just follow that down, right?
What do you
20
mean?
is the power coming down through 18.
Yeah, but that, we had left that unchanged.
Yeah, but we didn't.
But when you first turn on the switch, it'll go up there and energize it.
If it's normally
What
closed.
switch though?
See, this switch is over here,
Energizes circuit,
comes
okay.
over here, comes up to D, and energizes, which opens that, turns the light out.
So
These
when
are
we
lights.
turned,
Yeah.
that one to the left
Yeah.
tank, that switch also
Then
moved.
this one gets moved because of this.
No, this
Yeah, but
can't
they
be
didn't really
moved, though.
say
not
that's what they were
it is.
doing.
We didn't move
They
this,
just
so-
said energize the circuit with the fuel tank selector switch.
What you gotta do in
The
these
left
questions, pick the fruit off the bottom, the ones you definitely know are gonna move. And
Yeah.
this narrows it down to one or two answers.
Well, it's not, I
And
mean,
then
that
you
makes
can
sense
throw the
why it's
one
moving,
out.
but the question's a little misleading, because it's almost like saying, by switching that.
See, because if you're saying this is getting energized, then this is too.
Yeah?
Which means
Three
at that point,
circuits.
you got all kinds of stuff going
We got
on here.
everything going
Like,
on.
What are our
like
other
I
answers?
understand why 16 is.
What are my other answers that have it as an option?
3, 5, 6, 7, 11, 13.
So,
3,
So
that's
there's-
not really, okay. 5, 6,
Throw out the ones that.
That
Five,
one's, that one's
six,
missing
12.
12 though.
11, and what?
13.
Or
I have 11.
13, where's 13? 13,
So that's
where's
totally
15? actually
other
think
one
that's
is
the right answer, isn't
11,
it?
12, 13, 15.
What are they saying is the right answer?
The one that ends in 16.
5, 6, 11, 12.
Oh, 3, 5, 6, 7.
Maybe you can read it here where the 16 goes. Okay, when the TCC relay is energized, it changes the position. TCC, this one, how did that get energized?
What is?
Well,
there's
here
not
on
even
mine,
relay there.
on
I
mine,
think that is
Are
for
they talking
16.
about this?
I think it's just correlated.
because like at the same time, all of this is happening. Current is flowing from the right hand 5 amp circuit breaker through switches 18 and 20. So then that would change that.
So they're saying now all of a sudden this is energized.
Yeah.
Well, that's always
okay.
energized, that's the bus.
Which, it makes sense why 16 is 1,
So
but the
why,
question's kind of misleading, because it's like, it's almost as if like, oh, it's dependent upon the switch. But
why
that's,
doesn't this have power until you flip the switch?
Well,
At norm,
norm is not connected to anything. There's nothing going to that, there's nothing going to that.
so once you switch it to any of these, then you get power to all those?
This,
No,
this
these
is
are
your
always
bus.
powered.
So if you're drawing a battery in,
So if there's
That's how your
always,
battery
if there's always power to that, then there
The
should be
switch?
power going here, which should
Just hold it where it's
hold
at.
it up.
I think that's their point, even though it makes no sense with the switch question. Like, I think that's why the switch
This
opens.
doesn't switch then though.
Yeah, I agree.
And it's drawn incorrectly. These have to only get power when you switch them to here.
Because if this one switches because all of a sudden now there's power that we didn't know about, then this one's also moving from power up here.
But that only get,
That
that,
only moves if that gets power.
so it's either 14 or 16. It's either or, right? And that's based whether power's coming through 17 to 19 or 18 to 20.
You guys are gonna need to take another break.
So like,
I think about
get
lunch
why
now.
16 activates, but it has nothing to do with the switch. The switch, like the fuel pump select. Like that has no bearing.
Well, and it might, when we get into fuel systems, they might pull this one back up.
I guess it would
There
if it's in the
might be
cross-feed
some
position.
assumption here that once we get to a cross-feed valve versus pressure valve.
Because then it would change it. But like normal right-hand tank, left-hand tank does not do anything. It changes nothing over there. But if you move it to cross-feed, then that gets energized. And then 14 would be 1, not 16.
Does it say anything about why? Like what happens to all the fives at the same time?
Well, they're all the same point, if you look. So this is a bus, so that's our positive off the battery, right? So unless that breaker trips, all those fives are all.
Are those breakers or are those?
Those are circuit breakers.
Those push buttons.
Those are circuit breakers. So all 5 points are all the same thing. So I don't know why they label them so many times, but you might say they're a 5 amp, but they're always powered unless a breaker trips.
Then this is screwed up.
Well, either screwed up or they're making you make some assumptions on when it's open, when it's closed.
Cause or either that or this has to switch for 16 to switch, so that there's no way that's correct. This somehow only gets power when you flip
Well,
that,
with
or
this, gets energized, cross-feed, it's when it's take it off. So that's why that switches.
It's saying in the question that because there's power coming through here already, that this isn't gonna switch. Because there's already a power coming through, so when the power stops, that's when that will switch, right?
Here is what energizes it. It's that dotted line all the way over this. So if you energize this little guy, these two are out.
they just say somehow when you turn it to here, this moves without any of this moving, which makes no sense.
We turn to right hand.
We turn to left hand. It says the correct answer is that this moves somehow without any of this changing.
The last paragraph.
At the same time, also, make sure it's flowing from the
question would have made more sense. If they would have said, energize the circuit and move the fuel selector switch to left in, then it would work fine,
And they didn't, that could make sense.
right? Because now it says energize the circuit and then, energize the circuit with the fuel tank selector switch. Selected to.
What's the very first part of the question?
So, energize the circuit with the fuel tank selector switch selects to the left hand. So, you are energizing the circuit.
So this is assuming there's
It's
no
kind of a
energy in the
misleading way of
circuit.
saying that. They would have said,
I'll
energize the
announce that.
circuit,
Yeah.
then move the fuel selector switch to the left-hand tank, and then how many
Yeah.
change, like,
So this is assuming there's no power going to it.
at first.
When they make, correct.
That makes a big
So,
difference.
here it shows, drawing shown without electrical power to bus.
Oh, yeah.
So, he's energizing,
Yeah.
and so that would, then everything falls into place.
Cause then
Yeah,
once you
because
turn
once you
it
turn it on, then
these both
everything
will
will
move.
This will move.
Wouldn't these move then?
That, no, the 20 would stay.
No, cause the switch isn't over and closed right now.
I'm right.
But,
Oh, cause it's a
these
manual
little
switch.
dudes are the motors.
Now,
That's not a relay.
if you close the FCF somehow, whatever that causes it, that would switch also to go that way.
Okay,
But-
okay, I got you. Alright, coming back,
That helps.
a little late. Leo found the solution to a little bit of one of the questions. The very first part of one of the questions on here, the way it's stated, at least in prepware, I don't know what the FAA says, is it says, energize the system, switch, but, it kind of throws it in really fast to say, okay, right now our system's not energized. So it's saying, okay, energize the system and switch to the left-hand tank. So part of their question was, because all of them are shown in the not energized position, as soon as I turn power onto my system, we go, oh, I have power now. Click, and this guy opens, right? So you'd have to trace it through and go, oh, whoops, click, that guy opened, and then, so I both energized it, and you could run through and say, if I'm energized, does anything else have power? I don't see anything at the moment. And then the next step would be, and switch to the left-hand tank. So we got one that already went click, and then we go click, which closes that one. Which powers this, which ultimately ends up switching this over after the motor runs, which would power that one, which closes this, and our light comes on. So it's a, I don't like the question, but that's how you read through. But that would be the trick to getting, I guess, that right answer on that particular prepware, which be interesting to see if that one's on anybody's written, because they like to use a similar diagram and they'll change the wording a lot. More often they're gonna ask you broken wires, or if the FCF relay is energized, will the fuel crossfeed valve be able to close? And you'd go, let's see, if that's energized, I want to have power to be, so I'm not gonna be able to close it. So, the way I would phrase is, I like the way you guys are thinking through it, and that's what you have to do as you're going. Once you get through our fuel system, stuff like that, a lot of these are gonna make more sense. Alright, so we're gonna go to this one. I tried to blow it up here. That's another push to test inside our green light and inside our red light. There's a little triangle there. This drawing gets a little bit tricky. That would be the biggest thing to point out, is inside the light, that's a push to test triangle that the FAA likes. So, if I have power on my bus, again, bus just means that's where my battery is gonna ultimately be connected to. Now, there's usually a master relay between the battery and the bus, but we'll assume that the master relay is closed for most of these, unless it says it's not, and then you gotta energize the system, but you guys get the idea. So that's what bus means. So, if I had power at the bus, where were my lights? I just lost them. Green light here. I can trace some power through wire 7 over to my green light, and I'd be able to push to test and the green light comes on. There's a red light, so I'm probably gonna be able to do the same thing. I can push to test and the red light comes on. So that's one of the biggest parts on this one that if you didn't know that's a push to test, you'd be like, what is going on with this? So this is very similar to the other landing gear system we had. They added some extras, and it has some labeling. It says switches shown, gear down on the ground. So this one's gonna show our squat switches, I believe, if we get down into the nitty gritty of this. And it says with the landing gear retracted, the red, so that's the question. The red indicator light will not come on if an open occurs in wire. So it's asking which wire for the landing gear. So if we were to backtrack and we'd say 19, what does 19 do? 19 comes off my bus, it goes to my up limit switch, and it does potentially, so that's a potential option. 7, that's feeding my push to test buttons. So, that's probably not gonna be it, because they're not asking push to test. So we could probably just get rid of 7. So that's the push to test line. 17, where is 17?
Push to test green.
Push to test green. So that's probably not gonna be it. So most likely it's gonna be 19, and we could just answer it that way. Now, that's one way to do it. The other way is to get to where you understand the whole system. So this system, we've got a couple gear switches. So nose gear down switch, and it already said it's showing us on the ground. So this one will go back and forth between down or not down. And then left gear if it's down, right gear if it's down. So those are just our, as the gear comes to full position, is it down or is it not down? We have the same setup here with these. Basically, those two are connected to the throttle that the pilot pulls. So if the pilot were to say, hey, I don't want any power to the aircraft, and it's showing it in the closed position, they're closed. So it's actually drawing these already closed, where that first drawing we had actually shows them open. So there's some assumptions there, and you'll learn more about those switches later. But so those are throttle position switches. Down limit, and I'm making sure I got these right. So this one throws in our motors, and here's our selector for, hey, do I want to run the gear up or do I want to run the gear down? So if we follow our power out, everything's shown down, which means the power is going to come through this down guy. And when the gear is not down, these switches would be in the other position. So that's the, I think this last piece I have to show you. It's saying down limit, it already said they're down. So if I'm not down, it's gonna be in this other position, which means my power could go through my switch, through my motor, and hopefully run it. This one would say, ooh, my relay has to be powered. How does my relay get powered? And gear safety switch. It's already showing the gear down, so if the gear wasn't down, this gear safety switch, that's the squat switch. So that one is, I'm gonna put squat. Is that how you spell squat? S-Q-U. Squat, there we go, in the neighborhood. So gear safety switch and squat switch, that's the one that when we're actually sitting on the ground, the switch is gonna be in this position. So if you're flying in the air, that is never gonna be in that position, it switches up to that one. So, that is where you would get, hung up on some of the questions. Do you guys have any of these ones up where it asks what the questions are going on? Alright, just this one? Alright, so if we wanted to go through and say, 19, what does 19 do? Is up limit switch, let's see here. With the landing gear retracted, so, oh man, retracted. So probably that one's closed. This gear safety switch is probably gonna be closed. My down limit switch is gonna be closed. And that one's gonna be closed. Nose gear down switch is gonna be closed. This one's gonna be open. This one's gonna be open. I think we probably got it all. Alright, so all that work, just to take out the first sentence, with the landing gear retracted, the red indicator light will not come on if an open occurs in what wire. So now we would go through and say, hey, how do we power that red landing gear light? Which is, I got neutral always, so 8 up, oh, well that was easy, wire 19. If you go through the work and switch them all. So that basically makes sense, is you gotta look real close at, well, it says down, let me go right on my paper and switch everything that needs to be switched.
One
Okay.
question asking what number 7 is doing.
Okay, what number 7 is doing? And we talked about 7 is basically supplying our power to the push to test that we talked about when we started. These are, I'm gonna call it tricky questions. They'll throw them in your general prepware. Hopefully you don't get too many on your general test. Once you get through the landing gear sections, airframe sections, these will all start, I'm gonna call it making more sense to you. I've said this a couple times, because you'll know the systems a little bit better. Alright, another push to test, which is kind of a weird one on here. You see the little triangle, right? So you gotta push to test to ground that thing. And essentially, in this one, I don't like the way they drew it, but if I push to test, it's saying, yep, we're gonna ground wherever it goes, and that'll turn the light on. So I really don't like the way they drew it, but I didn't get to be the guy that draws the thing. I think maybe what they're assuming is this little thing swings up when you push the push to test. Just not a good one. So we got a warning horn again, throttle switches again, gear switches, so left gear down would be to the right gear down would be to the right, control valve down is to the right, or not, neutral's to the right, which probably is gonna mean they're not saying it, but up is probably to the left. So, we'll just read the question. They're gonna say in other notes, the control valve switch must be placed in the neutral position when the landing gear is down to, so I'm like, oh, okay, well my landing gear's down. They say it has to be in neutral to do something, so I'm saying, oh, well it's in neutral now, so what happens when it's over there? Let's see, I would get power through my green light. So, permit the test circuit to operate? No, because the test circuit, if I push it in here, I'm gonna test it right off there. So that's not gonna be good, that's a bad answer. Prevent the warning horn from sounding when the throttles are closed? Maybe, because if we close the throttles, I could get power in through here, and if that switch was over to this side, the power could come all the way down through in the warning horn. So I'm gonna say, ooh, that could be a good answer. Let's see what the last one is. Remove the ground from the green light. Nope, it's not gonna remove the ground, it's actually gonna give it a ground. So I don't like that one. So, I go back to, yep, must be this guy here. So on all the questions, when you get one, I would highly suggest basically doing what I did, is say, does that one work? No, I don't think so. Does this one work? Maybe. Does that one work? If you just stop at this and go, yeah, that's it, and don't read the last question, it might make a little bit more sense. You might get the question wrong. But, so that's back to just the simplified version of some of them they give you. But those push to test on this particular picture is just a strange drawing for it. Alright, well that's some easy questions hopefully. What happens if line 9 breaks, Josh? Or what doesn't happen? Might be an easier question. Yeah, our green light's pretty much not gonna function. Unless we use the push to test button, right? Yeah, so, yep. How about, whoops, what was my next question? Charlie, what happens if wire number 2 rubs through the insulation and grounds out? Like, oh, rats, I rubbed through the insulation and grounded out. Is it gonna short the system? So the way it's drawn is that would supply a ground here, which means my red light's gonna light up. So I would have a ground there and my red light lights up. Any other thing that would happen would be something to do with if my throttle's back, my horn's gonna go off continually. So that could be another thing that happens, right? But, so it's supplying, and that's why these ones are a little bit weird in what they're showing. I think if you were gonna draw the filament in there, you'd draw the filament kinda like that. And push to test swings this little lever up to that, is what they're essentially showing, but it's a little weird. Alright, I got one more just for the fun of it. What was my last one? What happens if wire number 7 grounds out, Leo? Yeah, I'm gonna have 24 volts direct to ground, right? So this little circuit breaker here is gonna hopefully pop before our wire burns up. So the answer would be we'd trip our circuit breaker because we have a short right from our bus right to ground. So that's the kind of idea that they may ask questions like that, and or if you're actually troubleshooting in the system, you're like, man, my breaker keeps tripping. Well, you start eliminating wires, and where am I gonna try to figure that out at? Alright, I think we already did this one.